Okay, the transcription just finished. It took all of 2 minutes, and here it is. Merging of two rivers, the kind we've seen recently in politics in the world. There's a very big issue. Lots of stuff that came from transcribing this Denver City Council meeting. And I'm just going to store that in a variable open source transcription, because now we're going to use the other way of doing it. We're going to use OpenAI. It has a GPT-4o mini transcribe. Now, I just ran this and it cost me 3 cents, but I'm not sure whether that was doing it once or whether that's because I ran it twice. So it's either cost 1.5 cents or 3 cents if you do it. So you would have to be comfortable with that spend, or you could always check whatever the latest pricing is of this. But it's certainly not more. It shouldn't be more of that order. But as always, don't always have a minimum spend on your key if you're ever concerned about this stuff. Okay. Now, the first thing you need to do though is, if you want to do the closed source, and this is optional, you can just stick with the open source one. If you want to use the frontier model, then you need to go to the keys over here and make sure that your OpenAI API key is here. So it's got to look exactly like that, not Open API key, but OpenAI API key. You remember that? It's got to be exactly right. You've got to have your key in the value. You've got to have it turned on, and then you'll be able to have access to that. And so here we do it. We get the audio model is GPT-4o mini transcribe. This is where I collect that key that we just put over there. This is where I create a new OpenAI, passing in that API key. And then I call transcription is openai.audio.transcriptions.create. I pass in the audio model name, the file, and the response format. And then we will also print it. Let's see what it comes up with. Leave it running and I'll be right back with you. And OpenAI finished, and it took all of 27 seconds. It was faster than the 2 minutes. And you can see just visually looking at the print there that it appears to be pretty similar. But look, where one of them, where the open source one put a comma, this put a full stop, just showing different interpretations really. But otherwise it looks pretty similar. We can print them both one after another. I noticed that one of them is slightly longer, so maybe there's a max tokens I want to set somewhere if I wanted to get the full thing. But otherwise they look pretty similar. And you can just choose to run one of those two, but I wanted to show you the use of pipelines, some good practice there, and back to using the OpenAI API as well. So we've got some frontier model in this too. Okay, that is step one. We've taken some audio and we've turned that into text, speech to text. So now we've done text to speech in the past, speech to text today. And we've also, of course, done image generation too. So we're covering lots of modalities. Anyways, next step is going to be to analyze this transcription and produce a report of the summary of the minutes and the actions. Let's get to it. And so, as usual, we focus on our prompts. I have a system message. You produce minutes of meetings from transcripts with summary, discussion points, takeaways, and action items in Markdown format without code blocks. And the user prompt is below as a transcript of a Denver Council meeting. Please write minutes in Markdown without code blocks, including these things: summary, discussion points, takeaways, action items with owners. And then there is the transcription. Maybe we should put in this might make it clearer. Transcription. Like that, an extra space. So that's a nicely laid out. You might say there's a bit of repetition between these two, but repetition is never a problem. In fact, it's always a decent idea to try and say things a couple of times, because you're biasing the model to be that much more likely to adhere to your task, to be aligned with what you want it to do. So let's run that. And now we're going to use bits and bytes to quantize to 4 bits. You remember this? This is the NF4 data type that you can look up to find out more about the normal distribution, so that the 4-bit number with 16 possible values can be mapped to a floating point space. And now here, of course, is the simple open source steps. We get LLaMA's tokenizer. We set the pad token to be the EOS token. How could you forget this? Doesn't everybody set the pad token to be the EOS token? All right. And then we take the tokenizer, we use the apply chat template utility so that we can pass in these messages and turn it into a sequence of tokens with the special tokens slotted in there. And then we get the return tensors in PyTorch style that's needed so that we can put it on the GPU. And if this seems, that practice is how you will get familiar with this. You should do this yourself and run this and look at it. But basically, it's something you just do by rote. This is how you do it. You apply a chat template to turn messages into a sequence. You turn it into PyTorch. You put it on CUDA. This is the streamer thing that I introduced yesterday, that we're going to create a text streamer telling it what tokenizer we're using. And then finally, the big guy, we take our model. It is the auto model for causal LM language modeling. From pre-trained, we give it our LLaMA model name. We say we want it on the GPU. We're going to quantize. And then we simply say, generate the output and use this streamer so that you can stream the results. And we run this, and it's now it's going to load in, first of all, LLaMA. Now here I'm suggesting you use a different model to yesterday, the 3 billion parameter version of LLaMA. So it's a bit chunkier than the one we did yesterday. And my GPU is very, very tight. I'm not sure if this is gonna run, because it's the second time I'm running it. Hopefully it will. Keep an eye on that. It's always worth looking at it on your computer too. Make sure that your GPU memory is good. It's loading this in. So far we're doing fine. And of course, if you've already run it, then it should be faster the second time. Here we go. It's running. And this was the input going in right here. And here we see it streaming back results. Our LLM call is coming back with a transcription, with a heading, the summary, 11 members, the location, the discussion points. Councilman Lopez presented Proclamation 1127 in observance of the second annual Indigenous Peoples Day. Councilman Lohman, takeaways, action items, additional notice. A lot about Councilman Lopez obviously had a lot to say in this meeting. There we have it. This has been the results of our LLM reporting, summarizing, and giving the action points and takeaways as a result of the Denver City Council meeting. It has been successful. But obviously, we don't know for sure it's been successful until we've seen that markdown printed out nicely. So here it is. This is the summary formatted nicely, the Denver City Council minutes summary. There are the attendees, the discussion points, the takeaways, the action items, and the additional notes. So there you have it, generated by LLaMA 3.2. If you use a bigger model, you can get, of course, different kinds of results, but this all ran for free, except that one of the alternatives was all completely for free. There was also the alternative to have spent 3 cents doing the transcribing. But other than that, this was an example of using free open source models in order to build some commercial functionality. This is actually a capability that is built into different commercial products like Zoom and others and many others. And so this is something that you know how to build yourself now with open source. And you can do it, and you should do it. And I put in here a student contribution that builds stuff and put it. Ahmed put this into Gradio, which is really cool, and you can do that too. There's so much you can do with this to turn it into a fully baked tool, and you absolutely should. This has given you some building blocks to experiment with, and the best way to build the expertise you need is through practice and building. Use open source models, experiment with them, and build stuff. If you can think of parallel ideas of how you could apply this directly to your business, then you should do so. And take a look through this, make sure you run this yourself. And if you come up with something interesting that is a different twist on it that you'd like me to add in here, please do send it to me, and I will add in links to your projects too. Since it's not so easy to do a PR for collabs, that's the way I'll do it. I'll include your examples in here so that other students can get to see your work. Anyway, I hope you enjoyed that, and I will see you back for the slides to give you your assignment and for a wrap up.